Hey, how are you? I'll be with you in 2 minutes. I just want to start the meeting on Teams at the same time, and then I'm going to share the screen for both. Okay. Hey, how are you, people on Teams? Okay. Share screen number 2, and share here. Not too many people showed on Teams, but more had attended on the Canvas. Sorry, on the on Zoom. How are you doing, guys? That's good. Enjoying the holiday? Yeah. So when did you finish the work? That's good. That's good. Yeah. Good thing that this summer is not that hot, which is good. So far. Yeah, I know. Too much raining. I hate rain. Okay, so as I told you that we're running this session on both Zoom and Teams at the same time because some of the students who want to participate in this session, they don't have a live UTS account, and that's why I'm running on parallel. But in both cases, the recording will be happening on both sessions at the same time. So the people will receive the code for the recording as soon as we finish the session. So I need to start recording now. Actually, the Zoom is recording now, and I'm showing my camera here, so they cannot see me on Zoom. But anyway, they see the screen now, guys. Can you see the screen on Zoom? Can you see it? Yep. Good. Okay. So as I told you that today's session is going to be introduction. I'm going to teach you the principle of the coding. This coding is not that hard, but it's very important. Now, even if the people say, okay, now everything is going to be done by machine in the future, but my concept is not. And also, I think that we need always to learn about the concepts, and then we start to develop it, and we will be able, of course, to compete with many things. Other people will say, okay, now the programming of these task is going to be done by technician. It's not going to be done by the engineers. I can agree with that, but at the same time, we should know that the engineers should be at the higher level than the. It's not something like I don't want to say that we are going to have multiple level, but the same thing. We need to be at higher level than the technicians. So one of the things I always suffered in my life was when I go to a new place as a junior engineer, that's of course was a long time ago, I always get the technician try to make fun of junior engineers. So if you are going to be able to know what they know, but you are going to know it from the engineering point of view instead of the technical point of view, this will be a good advantage for you over them. I know that the student who just did the the manufacturing engineering, maybe you missed many of the concept about the calculating all the forces we require to do the cutting. This is very important thing because, or maybe we learned that in the major project, the hand tool project, when we said that reducing the time of the assembly or the de-assembly or the machining, we are going to save money. And of course, we're going to save energy at the same time. Selecting the proper manufacturing process is going to be a good thing for saving energy, which is something we need to learn toward what we call the clean manufacturing. You know that all the world try to have a target of 2030 or 2050 for Australia, for example, on how to cut the consumption of the energy, and thus we're going to reduce the emission of the CO2. That's one of the points that you can understand and the others cannot, because simply you are engineers. Well, I don't want to go further in this point, but I always had this story about when I was trying to write down the syllabus for TAFE Australia. At a certain point, they asked me about write down how we can save the energy, save the environment when we do the brazing process. If you remember what the brazing is a process of the welding, but we're going to do it with lower melting temperature metals like the copper and the aluminum. So my suggestion was, okay, now just increase the oxygen instead of using the acetylene. We're going to have a higher temperature, again, to be able to melt the filler at shorter time. And of course, the oxygen burning is not going to be harmful as you're going to burn the acetylene. That was too much scientific thing for the people. When they try to assess what I wrote, they said, no. You can simply say they can do the brazing in good lighting place, like natural lighting in place, like they can do the brazing outside instead of the inside. That's a good concept, but what will be the case, for example, again, to have it in any closed area, like it's power plant, or maybe it's going to be an air conditioning system, which has been installed in the basement. I cannot take it outside to do the brazing. Okay, so that's one of the concepts, and now we're going to talk about the G coding once again, because this will be the language the person is going to talk to the machine. What we're going to have in this short session, which is going to be consist of 6 individual occurrence, Monday and Thursday, every week for the next 3 weeks. First, what are the G codes, why we need them, and later we're going to have some exercise. This will be started by Thursday. Later we're going to learn on how to upload the code we are going to generate to simulator, because I don't have a machine. We don't have a machine. So later I'm going to guide you on how to download a simulator, and you are going to start with the G code for milling operation. And later we're going to do the same thing for the turning operation. And the last 2 sessions is going to be about the CAD/CAM, how to use the SolidWorks to make the shape of the components we would like to make, and then we're going to generate the G code for it by using something called the CAD/CAM app, which is something we have as SolidCAM. One last reminder before we get to start the session is the difference between the 2 main operation of the machining. We have the turning and we have the milling. And the turning operation, the part usually is going to have a cylindrical shape. It will be held by the jaw on the machine. The spindle will rotate, again, to have a cutting tool, have a sharp edge, start to move and make the shape required. Okay, that's the turning operation. And the milling operation, the part is going to have non-symmetrical shape. It's going to have something like a rectangular shape or square block or whatever the thing is, the cutting tool is going to be the part which is rotating. The part is going to be fixed. The cutting tool is going to make some maneuvering and movement, certain height in X direction, Y direction, and the Z direction to make the final shape of the part. Now, how does the movement of the cutting tool going to be happen? It's going to be done by the G coding. So as you can see in this slide, we're going to talk about the G and the M coding. Now we have another term, which is the M. G usually is going to be for the coordination, and the M is going to be for the machine parts. Okay, now you can see that the G is shaping of the geometry. So the G is linked to the geometry. The M is for the miscellaneous things. So this is an example on how to have a G code to move the cutting tool. Is going to be these green cycles into a movement that cut the profile shape of the part in front of you. You can see that the center of the cutting tool, I need to take the laser thing, take a point. You can see that the center of the cutting tool is going to be here, but the cut we are going to have is going to be the dark line here. So you're always going to remember that when we're going to do the cutting, we're always going to have some offsetting for the center of the cutting tool, especially in the case of the milling operation and in the process of the profile cutting. Now, if I'm going to cut around, I call this cut is a profile cut. If I'm going to cut this face, I'm going to call it face cutting. And I think that most of you remember that terms. So you can see that what we have in a simple code are, first, you can see that we have the N starting from 1, 18, ending at 19. Sometimes we make it as the N10 and ending by the N190. So we are going to make it as 10, 10, 10, 10 for each line. Now, why we're doing that is going to be good exercise actually to have the chance to change by the code by or simply fixing the code. For example, again, to have a mistake between these two lines, I can write down the N51 and delete the N50, and thus I'm not going to have any problem. Okay, so what we can see here that we have the G05, we have the M03, we have the comma, we have the G0, we have the G01, G03, we have G02, and so on. M02 is at the end. This will tell me exactly, and of course you can see that everything is going to be followed by the X, Y, and Z, which is going to actually lead the cutting tool face center to a certain position in the X, Y, Z coordination. Where we can use the G code, this is example of 3D printing. So actually in 3D printer, the head of the 3D printing is guided also by using the G code. Of course, it's going to be much, much longer than the one we're using for the CNC, because CNC machining, because in the CNC machining, we just send it from one point to another. So we don't have to mention every point in the middle. While in the case of the 3D printing, we do the things layer by layer, and thus maybe the same code is going to be repeated multiple times. And that's what we call the caning, especially if we're going to have all the levels are going to be the same. But sometimes also it's going to have some differentiation between the shape because we may not have the whole things moving at the same pattern. Now, creating a numerical control part program. We can do that by doing the manual code writing, and that's what we're going to learn today, and we're going to practice it by Thursday. We need to visualize the machine operation from the drawing of the part. So we can either do the part as 3D part, or I can get the part, if I get to have a physical one, and I need to redo it, I will take the dimensions, select a reference point, reference all the points by the location from this reference point as an X, Y, and Z value, and then start to write down my G code manually. So the write of the machine-dependent instruction by using the GMM code. You can use also a computer-assisted programming. I don't want to explain that to you too much complicated, but this will be a high level of languages like the APT or the XAPT, compiled into a catalog location file or the CL file. So after writing down the code by using the machine, we save it as a CL file that will be sent to the machine, and the machine will process it. Now, the thing with the computer-assisted programming, if you ever use a simple programming language like the Arduino, for example, you have blocks. And the blocks is going to be about doing a certain operation. So I will import this block, and then I will put the P1 and P2, and thus the machine will understand it has to move from the P1, which is point number 1, to the P2, which is point number 2. And I can also define that this movement is going to be making an arc, or making a straight line, or just a point going down and up. So it's going to be mostly something like have a already defined things, and again, to make a relationship between these points to have this final shape. If you ever use the AutoCAD always had this probability. So I choose a point and I start to move the mouse, and I type, this will be LN, which is line, to location XY, if that can in 2D, or XYZ if I can sketching in 3 dimensions. The other way is the CAD/CAM generated programs, and this is the higher level of the writing the G code, and usually it's going to be done by do you still have me on Teams? I think I lost Teams. Just give me 1 second. I'm sorry. I lost Team. I just want to check up with them. Just to start it up. Okay, sorry, Teams people, I lost you. Okay, anyway, I'm going to share the screen again and continue with that. Okay, so I am sorry, but the program just restarted itself. Okay, sorry for that. The program just restarted itself, and we're going to continue with the slide. Okay, so as I told you that the last thing is going to be the CAD/CAM. From the name, we're going to use the computer-aided design, which is most of the people know it as the, when I say CAD, they will understand that we are going to have the geometry sketched by SolidWorks, or it's going to be sketched by the NX, or sketched by the AutoCAD. Now, the term CAD is computer-aided design, which is going to be, of course, sorry, the teams just keep breaking up. You're still with me, Zoom people, right? Okay.
I think so.
Yeah, still with me. As I told you, the problem we have is with the teams. I don't know what's happening exactly. So I'm going to join in, and I'm going to ask them to move to here. Sorry guys, but it's they don't. Oh, I think. So sorry guys, I don't know what's happening, but the teams is just keep shut down. So can you please move to Zoom? Do you need the code for the Zoom invitation? I can give you that. Send over again. Just give me 1 second. I need to send them the link. Oh yeah. So thank you, Sakib. Thank you for sharing that. But we need to share it on Teams. Yep. So I'm going to send it to them. Join now. Oh, keep shutting down. Oh yeah. Well, the problem is that the Teams itself doesn't work. And I need to send it to them on Teams. Okay, I'll try one more time, and I'll try to just paste it and escape. Just coming up and then turn off. I think that will be one of the problems we need to report, that the Zoom and the Teams doesn't work at the same time. But actually, I keep using the Zoom because the Teams, sorry, because some of the students are, I think, they prefer to use the Teams. And anyway, so sorry. Can anyone here access to the Teams and post that there? Because for me, it doesn't work. Please help me with that. I will ask Wajiha, because Wajiha has the first name in the front of me. Can you please do that, Wajiha? Just send it to Teams.
Yeah, I just send it. Hopefully it will come through.
Thank you very much. Thank you. Okay, so let's wait for them to show up, and we're going to continue with that. But once again, I'm talking about the CAD CAM. Now, once again, we said for the CAD CAM is we are going to build the part. Now I start to make a problem to my computer. Okay, screen sharing has stalled because the external display is disconnected. Okay, I disconnected the external display and start to do that. Maybe it was a wise thing to just restart the computer before I start the whole session. Anyway, just give me 1 second. Just admitting everyone here, and then we're going to continue with the screen sharing. Okay, so I'm going to focus on the Zoom. I'm not going to go with the Teams. Okay. Okay. I'm going to start the PowerPoint. I'm going to put the PowerPoint on the other screen. Share screen is going to be screen number 2. Share it. Escape the presentation. Put it on the other screen and start up. You know that technical problem always happen. Sorry, it's not my fault. Okay, so we go back once again. We said that we do have the CAD/CAM is the last process. What we're going to learn in this session is we're going to sketch the part by using the SolidWorks, and then we're going to use the SolidCAM, which is software available for the UTS student, to generate the G-code. Also, I went through the internet. I found something like the free CAD/CAM, which is a good software, but I'm going to learn how to use it, and I'm going to make a tutorial for you on how to use it. For the first 2 parts, we're going to use the manual G-code writing, because the second one requires a special software that I don't have, and I couldn't find actually a free copy for it. We go now with the manual numerical programming. First, we're going to learn about the G-code. I think I can use the camera now. Yeah, now it's much better. You can see me and hear me. Okay, so for numerical programming, we are going to use the symbol codes, which called the G and M codes, or the machine codes. Both names are going to be correct. We're going to run the part program to create the components or the parts of the machine. What we need to do is just write down lines, multiple lines. Each line is going to send the cutting tool center in the case of the milling, or the tip in the case of the turning, to a new location. It's always required to write down the location of the next point. We don't have to mention the location of the recent point. The movement of the cutting tool center or the tip, we call the tool path. And tool path is going to be defined by the line of the code, or we call it the block of the code. The line code begins usually with the block number. We need to define the block number by using the N, followed by the G code or the M code. The G code indicating the geometric motion of the tool, and that's why we call it the G code. The M code is miscellaneous or the machine function, like turn on the machine, turn off the machine, or hold the machine. You need to hold it, for example, to change the tool. The feed rates usually not going to be start with the after the at the beginning of the code. Like we set the feed rate by the F code, write down F, and then you follow it with number, which is going to indicate what will be the feed rate in millimeter per minute. It's going to be usually going to be happen after you say G0 to for example, to make the arc shape. You define the value for the X and Y location next, and define the R, which is the radius. Then you are going to decide what will be the feed rate. Also the S, which is the spindle speed. We have the S code, which usually again to write down the M03, which is start the machine, M05 to start the machine's movement in the counterclockwise direction. And then you are going to define the value for the spindle speed in RPM. So you just write down the M05, then you will write down the S, and you say, for example, it's 1,200 RPM. You don't have to write down the units because units can be simply defined by the setup of the machine. Most of the G codes are going to be usually followed by immediately X, Y, and Z values to show the next physical position of the tool center. The programming can be done manually by the part programmer or via the CAD/CAM software like SolidWorks with the SolidCAM, the Creo, or the Autodesk. The standard G and M codes, we usually have something about 90 codes, but we can write down a full code simply by using 5 of them. Okay, and well, I want to say 5 or 6 because simply you can remember that. Everything else, like turn on the coolant or turn off the coolants, or for example, make the offset automatically instead of finding the offset manually. This can be like the G041 and G42. This can be learned individually. Basically, what I'm going to teach you to this session is going to be the basic 6. Okay, and from the basic 6, you can extend doing that because I'm going to give you once again the link later for the CNC simulator, which can help you to develop your knowledge with the G coding. So we said that we have only few basic G codes that can be do the whole work. And a part of these basic G codes, all the other codes are simply going to be a combination of the basic codes written in the shorthand manners like the subroutines or the cane cycles. Subroutine, that's when I'm going to do the main work, then I'm going to stop the work for a while and then go do another things like make a pocket or maybe make a spherical shape, then return back to do the face cutting or the profile cutting. Also for the cane cycle, if I'm going to take the thickness of the part from, for example, 20 millimeters to 15 millimeters, I cannot do it in a single cut. For example, every layer I'm going to remove is going to be 2 millimeters. So I need to repeat the code 3 times, 2 millimeters, 2 millimeters, and 1 millimeter. So this process is going to be called the cane cycles. I don't have to write down the code multiple times. I'm going to mention that the following next steps is going to be repeated for 3 times with this depth each time. So the codes we need to learn in general is going to be the G90, which is going to set the absolute coordinates for the machine. By default, all the machines are going to be set up as G90. The other one is G91, which is set the incremental coordinates instead. Now, of course, you remember what the absolute coordinates and what is the incremental coordinates, but we're going to give you a brief about that in the next slides. G00 is going to be a rapid move from one point to another in a straight line without doing any work. For example, that's my cutting tool. It's at this position. I would like to take it to this position straight forward without doing any work. No contact between the cutting tool and the work part. Just say G00, X, Y, and Z. When I say X, then I keep sign for a while. That means you need to put a figure after the X. The G01 is going to be a straight line move at the set feed rate. That's mean in that case, once again, it's going to be straight cut, straight movement, but in this time, we're going to have a contact between the cutting tool and the work part. So we are doing machining. The G02 and G03 is cutting an arc shape. But the difference between the G02 and the G03 is the G02 is cutting in the clockwise direction. G03 cutting in the counterclockwise direction. So if I'm going to cut an arc to the counterclockwise direction, G03, set the X and the Y for the second position, the destination position, and then I need to define what will be the radius that the cutting tool need to sketch as the tool path. G02 is going to make it on the clockwise direction. M03 is start the spindle rotation in a clockwise direction. So usually, when I'm going to start the machine, no movement for the spindle if I'm not going to write down M03. Otherwise, the cutting tool will be in contact with the work part and it's going to be broken because simply when it's going to hit it without rotation, it's going to have the torque on it and it's going to break it. So just remember that you always have to check that the M03 is there. This will be the main thing that may damage your machine. The M00, when you finish all the movement and you want to stop the machine, you need to write down M00 to end the program and stop the spindle. But remember that you're not going to do that unless you're going to be sure that the cutting tool had left the work part. Other G and M codes are going to be different for each machine and controller combination. Even above codes can vary among the different machines and controllers. Some of the codes going to be mentioned later are G20 and G21, which is defining what will be the unit you're going to use. It's going to be SI unit or it's going to be the IP unit. Usually all the machines around the world are set up at the G21, which is using the SI units. In United States, they're still using the G20, which is using the inches and feet. Program line, we said that each line of the program has a standard form with a variation according to the particular motion required to the tool center point in the case of the milling, or the tip in the case of the technical operation. So every line, we call the block, is going to have first the block or the sequence number. This is very important because when the machine gives you the error, if you have one, it's going to mention that the line number 15, then you will be able to trace it directly. If you forgot to put that, it's going to be very hard to find when you try to fix it on the machine. Followed by the G90, which is set the absolute coordinates. G00 go a rapid movement in straight line to the X equal to 100, Y is equal to 50 millimeters, Z equal to -1, and the F equal to 100. Now, you can see that we mentioned the X location, the Y location, and the Z location. Of course, we need to have a reference point, and this reference point is going to be called the datum point. And we're going to talk about this one very soon. That's another example. And 30, G03 going to the X equal to -20, Y is equal to 30, the I is 10, and the J is 2. That was an old method to define the center of the arc when we're cutting an arc or circle. By defining the I and the J location, And of course, you know that according to coordination, we have the I, J, K, I for the X, J for the Y, and the K for the Z. And this will be the location of the center in this line you can see in front of you from the recent point. So that's mean the arc I'm going to sketch is going to have the stop point of the spin of the cutting tool center is going to be where the X is equal to -20, the Y is equal to 30, and the I is going to be shifted in the X direction by 10 millimeter to the positive direction of the X, and the J is going to be above by 2 millimeters. The program zero and the datum point that without it, you cannot find the correct movement of the cutting tool center. It's something like if you would like to drive your car and you are going to use a map, you need to have a reference point. If you're going to program your car, for example, it's going to, for example, a self-driven car. So in that case, set location, recent location, and the next location. And then the navigator will send again to calculate all the data for you. Now, for the zero data point, how you are going to tell where's the X, the Y, and the Z, you need to have a reference point. Where to put this reference point? Usually it's going to be on the top surface of the work part. And usually we are going to choose to be at the lower bottom left corner of the work part face. So a point on the job, and something can be on the stock material, chosen by the part programmer, to which all the coordinates are going to be referred to. So the origin of the system is going to be the 0, 0, and the 0. The location cannot be included on the program, but it's going to be implied by the coordinates of the toolpath. Usually, if I'm going to have a milling operation, I'm going to hold the part with a vise. Now, I need to be sure that the part is going to be at an upper level, okay? So the vise is going to be a little bit lower than the top face, and my datum point is going to be at this center. So when I'm going to take a look on it from the face, it's going to be here. So the vise is not going to be in contact with this point. It's going to be at the top level, and this will be considered at the 0, 0, 0 point. Below the surface is going to be negative Z. The longest side of the CNC machine and the milling operation is going to be the X-axis, and the third hand is going to be the Y-axis. In the case of the turning, usually we're going to have the Z point either going to be here at the end face. For the circle, this will be the X-axis going up, and this will be the Z-axis. The axis of rotation is always the Z-axis. The next axis is going to be the X, and if I'm going to have 3-axis machine, the last axis is going to be the Y. If you take a look next time to a table for the CNC milling machine, just remember that the longest side of the table is the Z, the shortest side of the table is the Y, and the vertical axis of the rotation of the cutting tool is the Z-axis. We're always going to have Z-axis in all operations. Even it's going to be a single axis machining like the drilling operation. And the other two axes is going to be the X and then the Y. The location has to be communicated to the machine operator using the drawings of the parts and the blank as appears before any machining. And for the basening up and checking that the program does not send the tool. Just give me 1 second. So just to be sure that we're not going to have any contact between the cutting tool and the machine table, we're going to have the program 0, most often for the milling operation, to be at the top surface, and at the bottom left-hand corner of the finished job. So possible location for the datum point, it can be here, it can be here, and it can be here. But usually we are going to adopt this one. This is the easiest one, and that's what most of the people agreed on. Oh, by the way, because the computer is playing full with me, I don't know. Okay, what I'm going to do is I'm going to share the main screen as long as we have a problem with that. Okay. Share screen. I'm going to share the same screen. This one down. Okay, I think this will be more convenient. Okay, so now we go once again to the coordinate system of the milling center. Whenever you can see a milling machine once again, just remember that the longest side of the table is going to be the x-axis, the shortest side is going to be the y-axis, and the rotation axis of the cutting tool is going to be the z-axis. In the case of the absolute dimensioning, all the points are going to be referenced to the datum point. So point 1, 2, 3, and 4 all going to have allocations, which are going to be defined according to the 0, 0 point. So when the absolute coordinate is going to be used, all the bits is going to be always relative to the 0 position, and usually going to be programmed by setting first the G90 code at the beginning. So I write down G90 code at the beginning, and then when I'm going to write down the X and the Y, the machine will understand that I'm referring to the 0, 0 point that's been defined on the machine. The other way to do that is by using the incremental, or what we call the chain dimensioning. And this is very useful operation in the case of the drilling operation, because we can simply define every next point to the recent point. Usually we need to write down the G91. Why it's not preferable to use the G90 and G91 for beginners? Because you may forget to change it back to G90 when you finish the G91. So you can write down G90, do the work, then you come to the drilling operation. Okay, and then you will simply go into, I don't know what the number of the error I just keep receiving here, but anyway. So G90, then you do the G91, do the drilling operation, where you define the next point to the recent location, as we can see here. So the point number 1 is going to be first defined with the reference to the 0, 0 point, because this will be my first location. So the G01 go to the X is equal to 1. This is the X direction, is equal to 1. And the Y is equal to 1.25. Now, to go to the point number 2, I will say just the Y is changing by the value of 1.5, because the point number 2 center have no movement to the x-axis from the point number 1, but it does have 1.5 in the y direction, and so on. Now we have another type of the coordination we call the polar coordinates. And I think that the student who did the advanced manufacturing with me earlier and they are here with me today, we remember that we made the car brake disc like the one you can see in the photo. We have multiple points. Usually these multiple points are going to be defined to the center in the middle. So we can simply say that we are going to have the first polar and the point is going to be divided by a certain angle. Okay, by defining with angles, this is what we call the polar coordinates. Now, this is not going to be actually working on all the machines, and me and the students learned a way on how to do it manually or by using the CAD/CAM, and this will solve the problem a lot. Now, the control statements is other than the G code we have, they don't involve any tool movement. So it doesn't have to do anything with the coordinates. And for instance, for example, we have the M03, which is set the spindle on. We have the F code, which is set up the feed rate. Like for example, the F200, that's mean the feed rate is going to be 200 millimeter per minute. Now, just to remind you that the feed rate in the case of the milling operation is going to be the movement of the cutting tool linearly, or we can call the speed of the cutting. Definitely is going to be different for the turning operation, because in the turning operation, the feed rate is going to be in how many millimeter you're going to move the cutting tool per revolution per minute we have for the part. We have the G05, which is pause or dowel for a given time, which will usually we do that when we change the cutting tool. We have the G25, which calling a subroutine, like changing the cutting tool, do a different operation like the drilling, then we go back to the milling again. We have the geometry of the property system statements, or the G codes like the G0, G01, G02, G03, and are all models and needed to be not to be repeated in the consecutive blocks. For example, if I'm going to do the G01, and next line also going to require G01, so I can save the time and don't type it again. Most geometry codes require to have coordinates, which usually going to have in Cartesian and using the X, Y, and Z form in the same block indicated on the next position of the tool, and always going to be a reference to the datum point in the case of the absolute coordination. We have the machine or miscellaneous statements, or we call the M codes, which once again not going to move the cutting tool, not going to turn on or turn off the cutting tool, have nothing with the movement, like the turning of the coolant off and on, like the M08 and M09 for turning off, to start the spindle in a clockwise direction, M03, to stop the program and set the beginning to, which is the M00. The first example again to have is how we cut a linear cutting. This is a piece of wood, and I would like to cut a straight slot inside it, starting from the point A, which is here, and end up at the point B, which is here. Now you can see that this is my datum point. I'm looking at the part from the top. I'm looking at the lower bottom corner to the left, and I set up my datum point here. Now, if I'm going to take a look for this part, is going to be at the top here. Now, this is the side view AA cutting. So you can see that the depth of the slot is going to be 5 millimeter downward. So what I need to move is the center of the cutting tool from here to here. The width of the slot is going to be decided by the diameter of the cutting tool. If my cutting tool has a diameter of 5 millimeters, that means the width between these two lines is going to be 5 millimeters. If my cutting tool is going to be 10, the depth between them is going to be 10, and so on. So the point A is 15 millimeter to the Y, 30 millimeter to the X. Of course, I need to say the other way, which is going to be 30 millimeter X, 15 millimeter Y, and minus 5 millimeter in the Z. Now, why minus 5? Because the top surface is 0, When I go into downward, it's going to be -5. If I go to be upward, this will be positive Z value. Sorry, negative Z, and this will be positive Z. So the code is going to be very simple. I'm going to move my cutting tool to the position where the center is going to be, I don't know why, yeah, above the point number A at higher level. Then I will send it down to a depth of -5 millimeters. Now I'm having the cutting tool inside the work part. Then I will write down G01, and I'm going to move the cutting tool from position A to position B. During this movement, I will cut the slot. Now I finish the cutting of the slot. I need to leave the work part. So I'll write down G01 or G00 and set up a new Z value which is going to be above the level. And finish. I cut this slot. So the code is going to be N0, that's line number 0, M03. That's mean the spindle start to work. Line number 2 is G90. I set up that the movement is going to be on the absolute coordinates. G00, that means the cutting tool is going to move from an undefined location to the place where the X is equal to 30 and the Y is equal to 15 and the Z is going to be equal to 5. So it's going to be above the point A. Now when I say 5, that means the cutting tool is going to be rotating at the top here. It's not inside the work part. It's above the work part by 5 millimeter height. Now I need to penetrate the work part to the depth of -5 millimeter. So I'll write down G01 to the Z equal to -5 using the feed rate of 100 millimeter per minute. Now I penetrated the cutting tool inside the work part. Line number 3 is move to the point where the X is equal to 80, Y is equal to 60 with the feed rate of 120. Now you can see that in this line, the movement we had was decided by the G01. But we didn't write down G01 because it's already been written earlier. So no need to repeat it. Okay, so line N30 or N3, we didn't write down the G01 because we already been defined in the previous line. Now I'm at the point number B. I cutted the slot in my movement and I need the cutting tool to go up. So we're going to have the line N4, G00, go to the height of Z equal to 50. Actually, we moved on 55 millimeters in this direction. And then turn off the machine by using the M00. That's it. I counted the slot. Now, the program 0 and the tool diameters is something you need to define before you start the operation. We need to decide what will be the tool, what the tools actually are going to use in your operations before you're going to start the machining. The tool diameters is going to be decided according to, for example, this example is going to be decided upon on the width of the slot you are going to be cut. Now, in the case of the circular interpolation, like cutting something like the horseshoe here, we are going to use a different code. Depend on, are we going to move it on the clockwise direction or counterclockwise direction? So you can see that the first line is going to be the same, M03. I just start the machine. Second line is G0, just go to the X is equal to 40 and the Y is equal to 60 at the height of the 5 millimeters. So I brought my cutting tool from anywhere just to stop it at the top of the point A here. Now, the next movement is G01. I need to penetrate the part with the cutting tool. G01, to the depth of 10 millimeters. So the Z is equal to -10 at the feed rate of 100 millimeter per minute. Now my cutting tool had went inside by 10 millimeter depth. Line number 3 is, now of course if I would like to go from the point 1 to the point 2, you can see that the movement, for the people who are looking at the screen, not looking at my hand, the movement is going to be on the clockwise direction. So in the clockwise direction, we're using the G02. The G02 must be followed by the coordination of the point I would like the cutting tool to stop at, which is this point. I need to give the X value, which is 15, the Y value, which is 35. The Z not going to be changed, so I'm going to leave it as it is. And then, because it is arc shape, I need to define the radius. So the radius is going to be the distance from here to the tool path. Of course, is going to be 25 by simple calculation. So I'll write down R25. Alternatively, I can use the I and the J. Now let's take a look because this will help me a lot. This is the absolute coordinates relative to the 0, 0, 0 point. The location of this center is going to be the I, which is in the X direction, is 40 millimeter, and the J is equal to 35. Now, these are the location from the 0, 0 point. Actually, this is shifted a little bit. Sorry for that. I need to push this one aside. Okay, so the location of the center can be identified by the I and the J instead of using the R. And actually, this I and J system can be more beneficial than the R value. And I'm going to talk about this one later. Now, if I'm going to use the incremental code, then I'm going to define the location of the I and the J with reference to the starting point. So you can see that this is my point of the starting here. The center in the I direction is 0 because it's going to be on the same action line. Sorry for that. Well, I have a suggestion. I'm going to restart my computer and come back to you. Don't leave the meeting. Okay, guys? Don't leave the meeting. I'll restart my computer. You got that?
Yep.
Yep. I'm going to restart my computer because I don't know why I have these technical problems. Just give me 1 second. I'll be back. I'm sorry. Here we go again. I hope that things is going to be much better this time. Okay, so what's happened to the camera? Okay. I hope we're going to have bad luck this time. Okay, we're going to play with the teams now. I think that's what's happened, that because I was running both at the same time, this caused me a problem. Anyway, we will see that. Okay, so once again, we go back to the slide. Yep. So once again, we said that we can have both ways to write down the G02 or G03 is simply by identifying, this will be for both, identifying the X and the Y for the next position, and then followed by the R and write down the radius of the arc I would like to have for the toolpath. Alternatively, I can define the center, and the machine will simply get to generate the arc. It's something like when you hold a rope with the pencil at the end at a certain point, and you move it, the radius generator is going to be length of the rope you have, because simply the center has been decided. So when we reach the next point, we need to simply leave the work part, and that's why we wrote down G00 to the height of 50 millimeters. Then we move the cutting tool to the position where the X is going to be equal to 0 and the Y is equal to 0. And of course, Z will remain as 50. Then turn off the machine. Yes, I'll go ahead.
Sorry, sir, could you please explain the incremental coordinates again?
Okay, for this one, yeah, because sorry, I stopped at this one last time. Okay, now, when we say incremental, of course, we need to put here that this is G91, right? To be incremental. And now let's define where's the center from the red dot here, incrementally. You can see that I wrote down that the I is equal to 0 because there's no movement to the left or the right, just below. So in the x-axis, there's no changes. I is equal to 0. For the j, which is the movement in the y-axis, we're going below this point by 25 millimeters. So we wrote down that the j is equal to minus 25. Clear?
Yeah, no, that makes sense. Thank you.
Okay, now, again, as a beginners, I will try to relay on the R instead of the I and the J at the beginning. Later, I'm going to teach you the I and the J, because if I would like to make 360-degree movement, this is not going to be possible with the R. We need to divide it into two 180 each. But with the I and the J, we can go for even more than 360-degree. We can go for multiple movement. So if you ever seen the spiral cuts, for example, like the thread cuts on the milling machine, actually, we need to use the I and the J. And that's what we are going to notice later when we are going to write down the generate the G code with the CAD/CAM software. So once again, this is just repeating what's the absolute and the incremental programming. The absolute, all the points going to be defined to the datum point, and the incremental, all the locations going to be defined to the recent position. There's an example here, again, to share this slide with you. I'm not sure what will be the best way to do that, because I know that for this Zoom, the problem is that we cannot make a group and do that. So maybe I will try something else for the students who don't have the team account, but they check in with us from country that they don't have the teams. So I will try to put that in 3 places. This document is going to be on Teams, it's going to be on LinkedIn, and also again to put it on the WeChat. So again, to put my WeChat on Teams and link them, just in case if you would like to go to the WeChat account. Okay, now this is an example for the absolute and incremental programming for the same part. This cutting is what we call the profile cutting. You can see that we have two lines here, two color. We have the brown one and we have the pink one, or the purple one. The purple one is the cut we would like to have, while the brown one is the toolpath. If I would like to do profile cutting, I always just remember something. We always need to have an offset. Okay, we have an offset. Something like when you stand in the train station, you can see that we have the yellow line, which is going to have a certain distance from the curve to the train. Okay, now always mind this distance. This distance is equal to the diameter of the cutting tool. So the distance between these two lines is equal to the radius of your cutting tool. Radius of your cutting tool. Now what we can see here that we need to have the movement which is going through the brown line to perform the cut in the purple line. Analyze that. We move from this point to that point, we need to have the G01. From this point to that point, G01. From here to here, it's going to be on the counterclockwise direction, G03. G01, G01, because I know this is a radius shape, but because simply I don't want to have a certain radius, is going to be the radius of the cutting tool. So G01 only, G01 and G01. If I get to go the opposite way, the codes are going to be the same. The only difference is at this point, I'm going to have G02 instead of G03. All the points has been indicated, and that's what you need to do manually if you're going to write down the code yourself. You find the atom point, then you're going to define all the location, which is going to be the intersection of these two lines. For example, you find this is the point number 1, this is point number 2, point number 3, point number 4, point number 5, 6, and number 7. Well, I just numbered them randomly, going in the clockwise direction. Okay, so you find the points, and then you find a relationship between them. The relationship is going to be defined by the code you are going to write down. So this is absolutely programming. I'm going to define everything as a G90, so all the points are going to be referenced to the 0, 0 point. So the first movement is G01, x equals 250, and the y is equal to 35. So we moved from here, I moved to there. So the distance on the x-axis is 250. I consider this one as the reference point, by the way, 250, and the y direction is 35. Now I'm going to move upward by 160, which is 125 plus 35. I'm here now. Now G03, because I'm going to create an arc in the counterclockwise direction. G03, and I'm going to write down the coordinates of that point, which is going to be the x is 210. Sorry, I have someone coming. Yep. X is 210. You can see that 210 is 170 plus 40. Okay, 210 for the x, and the y is 200, which is the 160 plus the 40. Now, the next movement is I need to write down the G01 again. G01 going to the x is equal to 40 because the y hadn't changed. Now, next movement, I don't have to write the G01 because it's going to be G01 again. But in that case, I'm going down by 30 millimeters. I don't have to write down 30 millimeters because I'm defining this location to the origin point. So I will go down to the y is equal to 170, going to the x is equal to 0, and then going to the y is equal to 0. Now, have a paper and a pencil and try to exercise on doing that by the incremental. do that by the incremental positioning. Of course, it was going to be the same. We're going to have the G01 followed by the G01, followed by the G03, G01, 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 and G01. Just the points, the locations is going to be different because is going to be identified from the recent location. I will give you an example. This point is going to be moving from here to here by 250 and on the Y by 35. This will be the same one. I will give you the second hint is moving from this point to that point is going to be G01, Y 125. Because the Y is 125, positive direction. Then you can write down the rest. I will give you something about 5 minutes to do that. I'll be past the time, sorry for that. Anyway, just spend something about 5 minutes on that, and I'm going to show you the solution, and then we're going to stop for today and leave the rest for Thursday when we're going to start to write down a code, because I'm going to give you an example. We're going to have a shorter example, then we're going to develop that to something like, it's not going to be actually homework, it's going to be something like you practice on it, and then you are going to have a peer marking. So I'm not going to mark that for you. Your colleague is going to give you an opinion on your work, and you will give your opinion on his work. And then if you have any dispute, you will come back to me to help you with the correct answer. Okay, so once again, I ended here, and these are these easy points because, as you can see, that the numbers already were written. Now I'm standing here. I want to go to this location. So once again, I can write down G03, but I need to define the location of the X and the Y. So you can see that this point is away from that point by 40 millimeter in the X-axis in the negative direction, because I'm moving to the left. So the X is going to be equal to minus 40. The Y is going to be 40. The radius is 40. R is equal to 40 as what we have earlier. Just to repeat that, incrementally, I'm moving to the left on the X-axis, and this will give it minus value, minus 40. But going up on the Y-axis, again, to give it 40 value. Now, from this point to that point, I'm moving G01, X is equal to minus 170, because once again, I'm moving to the left. Now, G01, Y is equal to minus 30. G01, X is equal to minus 40. And finally, the G01, the Y is equal to 170 minus, and done. So that's the incremental. once again, the incremental is you put a coordination for yourself, the X and the Y and the Z. And when you start moving, try again to go to the right, this will be the X-axis positive value. If you go to the left, this will be negative value for the X-axis. If you go up, this will be positive value for the Y-axis. If you're going to go down, this will be negative value for the Y-axis. You got this point?
Yeah, thank you.
I hope I didn't confuse you again. Okay, so you can see that once again. Okay, so whenever we go right, it's positive. Whenever you go up, it's positive for the Y. Whenever you go left for the X is negative. Whenever we go down for the Y is negative. Radius compensation is the most important thing. If I'm going to have a cutting tool which is going to have 10 millimeter diameter, my tool path must be 10 millimeter offset from the cut I would like to have. If my cutting tool is 20, the offset is going to be 10. If my cutting tool is 2 millimeter, the offset is going to be 1. Now you'll say that there's no cutting tool with 2 millimeters. There are 2 millimeters. We can also use the automatic one, which is the G41 and G42. So I write down the code, which is going to be exactly over the dark line here. Okay? But at the beginning of the code, I'll write down G02. G41, sorry, or G42. G41, if I get to go on the counterclockwise direction, I'll write down G42, so the center is going to be offset by a certain value over the code going to the right. Okay, if I get to go counterclockwise direction, I will write down G41, and this will be going to the left. So this will be the left offset, this will be the right offset. Once again, I don't advise you to use it at this moment. We're going to learn about this one later. All the cases, don't forget that we need to offset. The tool path is always offset from the cutting path by the value of the radius of the cutting tool. So once again, the pink line is the tool path. The black line is the cutting path. And we are going to have all the points to be identified from the cut-on point. The easiest way to identify this location are, you have the part from the top. I start with the offset because this will be the easiest thing. We take a look from the part from the top. We sketch a lines which are parallel to these lines. Now we have this line. Again, to sketch a line parallel to it and offset by the value of the radius of the cutting tool. Sorry, there's a question here. Oh no, it's not a question. Yep, I will sketch this line, which is parallel to that line here, and offset by the value of the radius of the cutting tool. Again, to make an arc, which is parallel to this arc, and offset by the value of the radius of the cutting tool. And then again, to have intersection points. These points, again, to find their coordination, then again, to build a relationship between them. Done. That's as easy as possible we can do it. So tool compensation, we said always going to be equal to the radius of the cutting tool. We can do it within the program by using the G41 if again to go clockwise direction, G42 if again to go counterclockwise direction. But I prefer you define or you write down the code with the offset you decide. So okay, so don't make the machine doing that, because I notice many students who try to do the work and they end up either having smaller part or larger part because they didn't define the points correctly. Cycle statement is going to be last thing we're going to cover today. Usually when we do the face milling, we said that we have a certain depth for the cutting tool we can penetrate inside the work part. This will depend on the type of the cutting tool material you are using, the material of the part you are cutting, the cutting speed. If I'm going to cut wood, I can go directly for 4 millimeters. If I would like to cut steel, I can go maximum for 2.5 millimeters. Now, another thing is the cutting tool. If I get to use a carbide insert, I can go further than the high-speed steel. Another thing, the quality of the work I would like to have. If I'm going to have the rough cutting, I don't care about what will be the surface roughness we're going to achieve after the cutting. I can go for deeper cut. If I would like to have finish cutting, I need to go for the shallow cut. The thing is that if I need to do it multiple cuts for the same pattern or the same tool path, I don't need to write down the code multiple times. I simply going to define that this cycle is a cycle statement or the Kane cycle where the system is going to be repeated multiple times. We have a G code for it. I only need to define how many times it's going to be repeated and what will be the depth each time. So if I'm going to have 5, I can do it as 5 divided by 3 times. So I can find number 1.5, 1.6 something, and I'm going to put it to be repeated for 3 times. Okay, so for the rest, I'm going to send you the document, and we're going to have some practical work on Thursday. So what I need from you is going to be preparing a paper and the pencil, not pen, and knowing for the ruler, because I'm going to help you to learn how to make the hand sketches. Okay, so thank you for your attendance today. If you have any questions, this will be time to ask, and then we're going to set the preparation for the next meeting. I can send you a hand sketch, and you can prepare on putting some points around and write down your own code. And on Thursday, we're going to start to have the exercise, the actual exercise that is going to be, once again, it's going to be a peer marking between each other. Okay, do we have any questions here? I hope I didn't take you for a dark point. Sometimes happening. And that's obviously because I spend more than the 60 minutes. Okay, so do we have any questions here?
No, for me, all good.
All good. Now, in general, the problem is that I don't know how to do that here because I'm not a big fan of Zoom. But out of, no, it's going to be very hard because as I told you, I'm not a big fan of the Zoom, so I don't know how to create a pool or to check what will be your satisfaction. So in general, out of 1 to 10, how much you learned? Just type that. This will be the best way. So it seems I didn't take it to a dark point. That's good.
And sir, can you upload this PPT on Teams if you don't mind?
I'll put it on Teams. I will send it to because some of the students are not from UTS. I'm going to put it also on LinkedIn, and I will try to send you the link for the WeChat. I'm going to put it on WeChat as well.
Perfect. Thank you.
Thank you very much. Okay, guys, thank you very much for your attendance, and sorry for the extra 30 minutes we have. And I hope to meet you on Thursday. Oh, by the way, I need to update you with that. I won the prize that I told you about earlier when you sent me the, what they call it, the testimonies. And I don't know how it's going to be useful to me, but anyway, I want something is going to be on my report. They call it the Teaching and Learning Citation Award from the UTS, which is good. Thank you very much. It wouldn't be happening without you. No subject is successful without the students. That's my theory. Maybe other people think the opposite, but I think that you made it good, not me. Thank you very much once again. I get to stop the recording now. And thank you very much. See you later. I'm going to upload the video to YouTube as well, and maybe the Bilibili, and share the link on Teams, and share the link on LinkedIn. Thank you, and see you later.
Thank you.
Again, thank you very
Yes.
much.
Thank you.
See you. Bye.
Thank you. Bye.